All right, class. So we're going to take a step back here and talk about why your chemical reactions and your Lewis structures are important and how they connect. So first I want to draw your attention to this part of your project shortly after part one. It's about ferric chloride and trichloromethanes. And by now you should understand that the excess chloride in the water is the catalyst to corrosion. So that's what sped up the Flint water crisis after the orthophosphate was no longer added to the water. Well, the problem of having too much chlorine was a response to having E. coli in the Flint River after they first switched. So after they changed from Detroit to Flint, they had a lot of E. coli in the water, and that was a problem. It was messing up with people's stomachs. So what they decided to do was add chlorine, which is a water purifier. The form of chlorine they added to the water is ferric chloride, which you see right here as the second product in your first chemical reaction. And I even have the title there. So what you need to take away from that is E. coli's in the water, E. coli's bad, so they add chlorine in the form of FeCl3 to make the water good again. Think about how many chlorines are in ferric chloride. That's going to be a recurring theme throughout the rest of our reactions. So remember that there's 3 chlorines in this ferric chloride for now. Well, then we come down to this series of reactions. So they add the ferric chloride to the water. Well, here's the process of that. When they mix the two together, H2O becomes ionized into that. But the main thing you need to understand is the ferric chloride decomposes to Fe3 plus and chlorine minus. So let's talk about why the 3 chlorines are important here. If I look at my reactants, I have 3 chlorines in FeCl3. And if I look at my products, I've only got 1. So what do I need to do? I need to balance this reaction and add a coefficient of 3. So now, how many chlorines did I have in FeCl3? I had 3. So now, after it's decomposed, I have, in a balanced reaction, 3 chlorines. Well, what do those guys go on and do? If we come down to the Lewis structure reaction, we realize that the chlorine has reoccurred again. So our chlorine friend is back, and it's in the same number. So our 3 chlorines from our decomposition reaction of FeCl3 came down here. Well, what's the rest of that molecule about? What's the rest of that compound? Well, if you guys remember the Scientific American video, if you listen carefully, they say excess chloride in the water bonds to organic matter in that water. Anything that's organic has carbon in it. You can't be organic if you don't have any carbon. Well, if you look at the rest of this molecule, carbon, 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 which means that this is our organic material in the water. I'm going to write org for short. So you need to understand that this guy's organic, and our 3 chlorines from our decomposition reaction have bonded to the organic matter in none other than water. Well, what's the point? Why should we care? Well, as it reacts in the water, as those chlorines bond to that organic matter inside the water, we get a byproduct here that we don't really care much about, but we do care about this guy. Now, if you look in the bold print above this reaction, trihalomethanes. Trihalomethanes, what does that mean? I've got 3 halogens on a methane. A methane is a CH molecule. You've seen methane in methanol, which was CH3OH. We talked about that in the Dakota Access Pipeline. Well, trihalomethane means you have 3 halogens on a methane. In this example, guys, we are just focusing mostly on the chlorine in the water. So we picked the halogen chlorine. So there are 3 chlorines on this CH molecule. And what's the point? Why do we care? Well, that's another name for chloroform. Okay? Chloroform is one of the toxic trihalomethanes produced from excess chloride in the water purification. It's also called trichloromethane. So what you need to take away from this reaction is, what are our problems that are generated when we add too much ferric chloride to the water? Well, to do a quick recap, we had E. coli. E. coli bad, so we add ferric chloride into the water to make it good again. Well, the ferric chloride decomposes in water, and then it makes our 3 chlorine ions. Those chlorine ions want to bond with somebody. So where do they bond? They go to our organic matter right here, okay, this guy, and then in the water, that organic matter with the 3 chlorines attached makes this guy, chloroform. Chloroform is bad and toxic, and that is just one of the problems with Flint water. So I hope that helps. There is one more thing I want to show you about your reactions. So we talked about what's the problem with the chlorine. Well, we didn't pay much attention to this guy. So when we add the ferric chloride into the water, it causes the water to ionize. So we have H plus ions, which are just protons, and then we have something called a hydroxide ion. You don't need to worry too much about those. But where that leads us is we have the Fe3 plus that came from this guy. So when ferric chloride decomposed in what we talked about earlier, that iron, well, whatever happened to him? He came down here and bonded with that OH from our ionized water. And what happened there was they made this guy, FeOH3. What's the big deal about FeOH3? Here's the connection. If you go onto YouTube and you look up a video of Flint tap water, people are going to fill up a glass of tap water, and the tap water is going to come out orange. It's going to look like Gatorade. Well, why does it look orangish brown in color? Well, what did we create from this third reaction? We created ferric hydroxide, which is an orange-brown solid that is slightly soluble in water. Where's the connection? Orange-brown solid, slightly soluble in water, orange water. If you guys have any further questions, feel free to send me an email, come see me, but hopefully this should clear up stuff. In terms of your final project, I do want to see your Lewis structures, because your Lewis structures show me that you see those chlorine ions. What happened to them? They bonded with the organic matter. That's the importance of this whole thing. They bond with the organic matter to make the chloroform. Okay? You also need to include all the lead and stuff, but this is why I chose your reactions. So in terms of the balancing and the reactions and the Lewis structures, that's why I want to see that in your final project. Again, send me an email if you have any questions, but I hope that clears things up.